This is a resistor. It has a specific value, and when I put a certain voltage through it, it should resist the current, bringing the current down and turning the extra energy into heat. So let's heat it. I think my resistor is too big. Oh. Yeah, I think my resistor is a bit smoky. That happens sometimes. Here, we have 3 resistors put in series. When you put resistors in series, you increase their total resistance. And when you put them in parallel, you decrease their total resistance. Because the electrons have many more paths to choose. I have that same circuit right here. So let's power it on. Now, a resistor is just a piece of metal that's non-conductive, but not an insulator. Copper is one of the cheapest, best conductors. Nichrome, on the other hand, is a pretty bad conductor. Nichrome is lazy. Resistors are made of nichrome, and nichrome doesn't want to do anything. It doesn't want to melt, and it doesn't want to conduct electricity. So when the electrons are pushed through by the voltage, the nichrome resists this change, wasting some power in the term of, and this is how light bulbs are made. When making the resistor, you just take the nichrome and you wind it around the ceramic core that takes so much temperature. But here I have other non-conventional resistors. I showed this copper pipe, which is pretty conductive. I use this as a resistor for my spark gap Tesla coil because this can resist like 3000 degrees Celsius. And I also use this as a big beefy resistor for charging up my supercapacitor bank. Pretty much anything can be a resistor. You can use this primary core as a resistor. Aluminum is about 40% as good a conductor as copper is, and nichrome is way down. Now I have this digital multimeter here, which has an ohm meter inside, and I can see the resistive power of the copper pipe is pretty low. Can't even measure it properly. Now I have this little circuit with a few resistors and the LED. Let's see what's... Always check your resistance with this. If I measure each resistor individually, they both have the same resistance. But if I put them in series, their total resistance is double. The resistance is half of what it used to be. I have this little circuit right here, and as we can see, the resistors are limiting the output power. This is 4 volts. This is 4 volts without the resistor, with the resistor. Now I'm making a voltage divider, so if I probe across these 2 spots, if I probe the positive and I probe the negative, but if I probe the negative and I probe in between the resistors, I get half the voltage. That's how our voltage divider works. And this is the graph I drawed from earlier. You can see by sliding my potentiometer, it changes its resistance a bit. My multimeter is not that smart though. I have right here a circuit, which is the beloved 555 timer IC. By adjusting this potentiometer, we can modulate this LED. It looks really slow on camera, but it's almost not twitching to me. This circuit uses the potentiometers and the resistor dividers I showed earlier and makes the potentiometer a part of the resistor divider and adjusting the voltage to the 555 chip, giving a variable frequency and duty cycle out. In AC circuits, you don't need to use a resistor. You can use an inductor, basically a ballast. This is what's called for input power correction. And basically you're using an inductor to create an AC impedance, or you could use a capacitor. Yes, this is a capacitor, it's for my spark gap Tesla coil. But if you use a capacitor, inductor, just remember, when playing with high voltage, you are a conductor.